The key message will be that near 1 trillion will be in This means basically that there is acceleration in the renewable terms, but we are also seeing that there is 960 investment in gas power generation and around 680 billions in coal fire, which means that the acceleration in renewables is also combined with acceleration in the use of gas. Now that we're seeing that basically in the use of turbines and hybrid systems, the combination with batteries, what we are seeing is that they need flexibility in the systems and reliability of the systems, where that most of these investment is coming along from China and also from the US, but Europe and Asia Pacific are also constraining this. Solar remains strong, as we said, but it's interesting to see that it's also a combination with other sources like wind, for example. We're seeing problems, for example, in US for offshore wind, but onshore wind is growing, and we're seeing growth for hydro in Latin America, for example. So solar remains the strongest one, but all the other renewable sources are growing. And we are also, as I mentioned before, seeing gas remain very stable during the whole forecast. That's because we're seeing more the use of hybrid systems, combination maybe with solar and batteries, maybe even hybrid system with a combination of multiple renewable systems in the same power plants where they're able to use solar with wind. And in all cases, they're also now transitioning in the use of solar plus gas and batteries, or maybe wind plus gas.
Governments have reacted with incentive plans that help offshore wind to some extent. And it is a key part of decarbonisation for a lot of European countries. Obviously, a lot of European countries have sea borders. They have good conditions, basically, for wind. The UK, where I'm obviously based, we are doubling down a bit on offshore wind. We're having significant investment. France, Germany, a lot of big countries are putting in there. We still see growth from China, very, very suitable for essentially supplying power to the East Coast. So we see those as being, I guess the key growth points for the next 3, 4, 5 years.
We're also seeing a trend in data centers that they're using gas turbines to deploy more temporary prime power. They're using hybrid grid connected assets. They're also using behind limited generation is raising fast in there. So, but in terms of gas, they use that the data centers are with the turbines is interesting because they are using hybrid systems. They are using systems and reciprocating engines in parallel. Now there are multiple announcements about 400 or 300 megawatts new plants built just for data centers, and that goes to the chart in the right hand, where we're saying that the on-site generation will change up to 30%, maybe, or near 30% by the end of 2030. We started in 2024 with a projection of less than 5% was on-site generation for data centers, and now we're saying that it will go up to 30%. So data center is not only using power, it's also driving the deployment of power and how it will be used.
The energy storage situation has moved from being really grid support to ancillary services now into being use cases that are spread across renewable integration, guaranteeing supply, helping end users avoid higher demand charges and costs, and then wider grid system support. There's definitely strong growth for storage overall across different areas. So you can see here, again, a bit more some of the different use cases and timing. And what we're also starting to see is longer duration for energy storage as well. So historically, a lot of the assets were considered for maybe up to an hour. You were really talking about frequency response, voltage support, it was more focused around minutes. We're now starting to see more systems being deployed with higher duration storage, so more focus on looking at 2, 3, 4 hours. And we're also starting to see more movement on longer duration storage. Grid enhancing technologies, we've spoken a little bit about the grid. There is lots of investment going into conventional grid infrastructure, so cabling, transformer, switchgear, to expand the network and to upgrade the existing network. But there are certainly technologies that can be deployed to make it operate more efficiently. So a few that I'm just showing here. A good example, dynamic line ratings, again, has not fully taken off yet, but this is really where you deploy more sensors in the grid, and effectively you can improve the amount of capacity that's being transmitted over a network. So again, mitigating the need to build quite so much in terms of new cables and new projects.